today we are going to talk about quadratic formula. What methods do we remember? How we can solve quadratic equations so far? Factoring. What else? We just did it last time. What did we do? Completing the square, and then one more. Square roots. Very good. So today we are going to learn the final method, quadratic formula, and the good thing is it works every single time. And you've also seen it before, so that's also good. Not new. What is new is that we are going to derive the formula today. Okay? So we will start with the equation, quadratic equation in its most generic form. Ax squared plus bx plus c, where a, b, and c can be any constant, any integer, any number. And we are going to solve this using the completing the square method. Okay? So where do I start? What do I need to do to complete the square?
Well, you subtract c.
I subtract c to get the constant on the other side. Very good. I have ax squared plus bx plus c equals 0. Oh, I just zeroed.
That would be negative c, right?
Yeah. So plus bx equals negative c. Okay. Now what do I do?
You would divide.
No,
No,
before I
no.
go there, what do I need to do? Take care of this a, right?
Yeah.
I want to set a to 1, so I need to divide everything by a. So what I have, x squared plus b divided by a, x equals negative c divided by a. Now I can complete this square. How do I do that? What do I do next? Yes, so I need to take my b coefficient, which is actually b divided by a already. But that's my kind of b in the standard form, right? I divide it by 2, and I take the square of it, correct?
Yeah.
Yeah.
Sure.
And so I need to add this to both sides of my equation. So let's do that. I'm going to take this and I'm going to add it to both sides of the equation. Plus b divided by 2a squared equals negative It's going to get a little ugly, but you just have to look at it. So now by design, this trinomial is what?
It's completed.
It is completed square, right? So I can rewrite it as x plus what? My half b. So I'm just going to take this b divided by 2a, right? My half of this coefficient. Slower? Yes, of course. Okay, so we are right here. No, not here.
No, like the middle.
Like here? Okay, so we completed this square, right? We added that b over 2 to the power of 2 to both sides of the equation. By design, this trinomial could be rewritten as the perfect square of what? X plus my half b, which is really b divided by 2a. Let's see. Right? And then I just rewrite the constant term over there. Minus CA plus B over 2A squared. Before we go further, let's simplify this constant term. Okay, so minus CA plus B over 2A squared, I'll rewrite it as minus CA plus, and then the square of the fraction I can rewrite as numerator, square of the numerator divided by square of the denominator. Correct? Just represent the square of the fraction. Took the square of the numerator divided by the square of the denominator. Now I can simplify a little bit further. So I just rewrite negative c over a plus, I have my b squared over here. And then on the bottom, 2a squared is just 4 times a squared, correct? because 2 squared is 4. Okay. And I want to simplify it just a little bit more. So I'm just going down here. You see how I can find the common denominator here? By multiplying the first fraction, numerator and denominator, by 4a. Can you see that? So if I multiply here by 4a and here by 4a, I will have two fractions with the same denominator, 4a squared. Do you see this? Hannah? Yes? Okay. So I'm just going to rewrite minus 4ac, numerator 4a squared, and then plus a squared over 4a squared. Yes? So now I can combine these two fractions, right? I can actually do the addition because denominator is exactly the same, so I can have a single fraction here. Let's scroll a little down, please. So I'm going to rewrite this as b squared minus 4ac. So what I did here, I switched the fractions, the places, and then I said b squared minus 4ac. Good? All good? Okay, so now, oh, how do I do this? I'm going to rewrite this statement, the one that I just left here, but I'm going to replace this constant term with whatever I got there. So what did we have? We had x plus b over 2a squared equals, and now this whole thing, b squared minus 4ac divided by 4a squared. See what I did? I just took whatever I had here on the right side, and then my simplified left, on the left side, and then simplified right side of the equation. Not simplified much, but it helps later. Okay, Pauline? A lot of variables, a lot of letters. Okay, so now, how do we solve this? I have the perfect square here and then the constant over there, right? Because a, b, and c are all constant. I know them. These are coefficients. So I can apply my square root method. So how do I do that? I just put square root and square root, right? So square root on this side and square root on that side. Then I'll just rewrite what's inside. And then I don't forget what?
Plus or minus.
Plus and minus, super important. Plus and minus. Okay. So now this crazy square root over here, right? I can, because this is square root of the fraction again, I can separate. I can have the square root of numerator divided by square root of denominator, correct? So that's what I'm going to do. My plus minus over here, and then square root of b squared minus 4ac divided by, and then the square root of the denominator is what?
2. No. Yeah.
Square root of 4a squared. No. Up? 2a, correct. So that's just 2a. Very good. Yes.
So
What if what?
what if the 4AC be 2 as well?
I'm sorry, I think
You changed the 4A squared. Why didn't you change the 4AC?
Oh, right. So because the square root of 4a squared, like it's just by itself, right? So I have 4a squared. This is all multiplication. right? So the square root of product is the product of square roots, right? So this is just like square root of 4 multiplied by square root of a square, so I can simplify each, all good. But when I'm looking at the numerator, I have the square root of the difference, right? So I cannot just take square root of b squared and square root of 4ac separately, because it's square root not of the product but of the difference. So it has to stay as this. Okay. So now the square root of this perfect square, what is it? It is just x plus b over 2a, right? Because square root and square cancel out. Almost there. See, we are getting there. So now I need to solve for x. What do? I just subtract this constant b over 2a from both sides. Right? And now I rewrite x equals negative b over 2a plus minus square root of b squared minus 4ac divided by 2a. And just one last simplification here. You see I have two fractions with the same denominator, so I can combine them. So I say minus b plus minus square root of b squared minus 4ac divided by 2a. And this is the formula you've seen before.
Yeah, I've seen that.
Right? Oh, no. Algebra 1.
They always put this on the things that they give you on the SOLs.
Yes. SL formula paper will have this. Pretty sure everyone have seen this before. Right? So whenever we have the quadratic equation in the standard form, ax squared plus bx plus c, we can solve it by just taking the coefficients and plugging them into this formula. Okay? Questions? You haven't done anything new, right? Whatever you did last time, whatever you did on the quiz today, whatever you did in the homework, those are the steps that we did. The kind of complicated thing was that we didn't have numbers, we had letters to work with. That's why it was a little bit like ugly and big. But all the steps are exactly the same. Questions? Great. So now just put this formula into your quadratic formula box over there. I think you have this, right? Just put it here. So minus b plus minus square root of b squared. I think my writing on the board improved so much since the first day, right?
It's beautiful.
It is beautiful. Oh, okay. You have it on the same page. I'm even making an effort to make my B look different from my 6. Okay. So, quadratic formula can solve any quadratic equation. We talked about this. In order to use this method, the quadratic must be in standard form. So this is where we have to start. Because this is what the formula is based on, right? These are the A, B, and C that we need to plug into the formula. So first, always have your equation in this form. So let's just practice. Plug it in. The example here, 3x squared plus 8x minus 3 equals 0. So first step, put in standard form. Do I need to do anything? Already is. So I'll just rewrite. It's already in standard form. Very good. Identify A, B, and C. So what is my A?
3.
3. What is my B?
8.
8.
Negative 3.
And then my C is negative 3. Okay. So let's plug into the formula. Here's our formula. So x equals minus b 8 plus minus square root b squared minus 4 AC is 3 and negative 3. So 3 and negative. And then I divide everything by 2a. So 2 plus. Just put f3 coefficient in the parentheses, just for now. Okay, so let's simplify what's under the square root. So I'll just rewrite x equals negative 8 plus minus square root, and then what do I have here? 8 to the power of 2 is what? 64, and then minus 4 times 3 times negative 3. What is this? It's 36, so minus negative 36 gives me positive 36, right? I mean plus 36, correct?
100.
Yeah, so it's 100. Let me just like do 100 here. You can rewrite it forward in space. So just put 100 here. And then divide it by 2 times 3. Now let's simplify everything else, minus b and 2a. So I'm going to rewrite minus 8, so it's just negative 8 plus minus my square root of 100. I'm going baby steps. I know you can like simplify it farther here, but 2 times 3 is 6. Now I'm going to simplify the square root. Well, this one is quite easy, right? So it's just minus 8 plus minus what? 10 divided by 6.
Oh.
Right? Square root of 100 is 10. Now there are two steps, 7 or 8, it's 4. If there is no square root left, find two final answers. If there is a square root left, meaning that we couldn't simplify it, we couldn't get rid of the square root or the radical sign, try to simplify all three outside numbers. So we are in step number 7, right? Because we don't have any square roots to worry about anymore. So let's simplify. How many solutions do I have here? 2, right? So let me find the first one. x1, it's minus 8 plus 10 divided by 6. And what is it?
1/3.
1/3. And then I have the second one. My second solution is minus 8 minus 10 divided by 6. And that gives me what? Negative 3. So I have these two final solutions. 1/3 and negative 3. So if I really want to,
Would you put that in the fancy bracket?
yeah, we can put it in the fancy brackets. So negative 3, 1. This is our final answer. And we are skipping 8 because it's either 7 or 8. Questions? Okay. Oh. This is wrong. I thought I fixed it. This is not what you have, right?
No. We
Yeah,
have,
you have what?
6p squared
6p squared.
plus 3 equals 8p.
Okay. So let's solve this one. Yes.
Can you go back
Yes.
to the very last box?
Good? Okay. So the first step, put in the standard form. Always, never forget, because the coefficients will change. So I need it in this form. What do? I subtract 8p. Yes. So subtract 8p. You can do minus 8p minus 8p. So I have 6p squared. I'll just put minus 8p first, just so it's in the standard form, plus 3 equals 0. Now it's in standard form. Now I can figure out what my A, B, and C are. So what is my A? 6. Just 6, right? Not P. P is the variable, A, B, and C constants. Okay, what is my B? Negative 8. And my C? 3. Very good. I take my formula and I plug in my coefficients. So x equals negative b, so negative of negative 8 plus minus square root b squared minus 4ac. 6. And the whole thing is divided by 2a. So 2 6. Now I start simplifying. Simplifying one by one. Start with the radical, whatever is under the root. So I just rewrite and only worry about what's under the root. So negative 8 to the power of 2 is what? Negative 8 to the power of 2 is 64 minus 4 times 6 times 3 is negative 72. So I have 64 minus 72. Gives me what? Negative 8, right? Negative 8. And now 2 times 6. Okay, we simplified what's under the root. Now we simplify everything else. So x equals minus negative 8 is positive 8 plus minus square root of negative 8, right? And then divided by 2 times 6 is 12, right? Okay. Simplify the square root, baby steps. So how can I simplify my square root of negative 8? Jaden. Oh, not Jaden, I'm sorry, Juvan. Okay, Juvan. Square root of negative 8 is what? I, because it's the negative sign under the root. And then can I simplify square root of 8? Not calculator, factor 3 in your head. Factor ladder. Right, so I start 8 divided by 2, 4, so what is this? Of 2, right? And then 12. Okay, so 7 or 8, right? If there is no square root left, that doesn't work for us. We still have the square root. We couldn't get rid of it. So now 8, we are doing 8. So this is skip. Now we are going here. So if there is square root left, try to simplify all 3 outside numbers. And also my suggestion always, if you see I, complex number, represent it in the standard form, right? Real first, imaginary part next. So like separate them, that's what I'm trying to say. So x equals 8 over 12, and then plus minus by 2 square root of 2i over 12. And now I can simplify each of these fractions a little bit, right? Because 8 over 12 is what? How can I reduce? 2 over 4. Is it 2 over 4?
No, 2/3.
2 over 3, right? Plus minus, and then can I reduce this? 2 square root of 2 over 12. How can I reduce it? 1/6. So it's square root of 2 over 6i. And that is my final answer. Questions? Any questions? Okay. So now that we have learned all 4 methods of solving quadratics, So what are the four methods that we learned again?
Factoring.
Factoring,
Completing the squares.
completing the square,
Quadratic formula.
quadratic formula was today, yeah, and then square root method. I'll just put square root. Square root method. So now let's talk about what we are solving for, right? So looking at these graphs, obviously we are talking about function, quadratic function here, right? So if you think about the quadratic function, f of x equals ax squared plus bx plus c. Solving quadratic equation ax squared plus bx plus c is finding what for this function? When I solve my quadratic equation ax squared plus bx plus c, I'm trying to find what? Let's say it again. No.
F of x.
Yeah, so no. So this is the function, quadratic function, right? When I set my function to 0 and solve it for x, what am I trying to find? What are the properties of the function? Specific points on those functions, on the graph. X-intercept, right? Of this function. So when we solve an equation for x, we are trying to find x-intercepts of the function. Right? So three possible outcomes. The graph of this function, quadratic function, is the parabola. You've seen this before, right? In algebra 1. Right? Parabolas.
We had them for years.
Okay, but you know the form, right? The shape. Parabola. Okay. So there are three possible outcomes. When parabola has these two x-intercepts, right? It means the quadratic equation will have two real solutions. Because think about it. We are setting y to 0. We are looking for the x's, right? So we are looking for the x values for the x-intercept points, right? These are two real points on the x-axis, right? So two real solutions to our equation. When I have the graph, when the parabola is above the x-axis, what does it mean? Do I have any x-intercepts? No, right? So when I try to solve this equation, when I set it to 0 and solve it, what do you think my solutions will be? Will I have any real solutions? No. But if I don't have any real solutions to this equation, do I still have solutions? Complex numbers, right? We still have two solutions, but they're complex, correct? So two complex solutions. And when my graph, my parabola touches x-axis in just one point like this, I have only one x-intercept, right? Will I have real solution or complex solution?
Real.
Real. And how many?
One.
Just one real solution. So these points that we are trying to find, right? You can call them what? We already said these are solutions. You can also call them x-intercept. We said that.
Ooh, a 0?
Yes. So we can call them zeros. And what was the last term that we used? Anyone? Natalie, do you remember what we called zeros and x-intercepts? Starts with R.
Root?
Anyone? Roots. Yes. Roots. Okay. Okay. So just by looking at the quadratic equation, Teddy, Will, don't fall asleep, Jose. Just by looking at the quadratic equation, how do we determine what kind of solutions we have and how many, right? If you think about our formula, minus b plus c square root b square minus 4ac. What do I need to happen to have two real solutions? No, let's just look at these are my solutions, right, in the most generic form.
Yeah.
What needs to happen here for me to have two real solutions? No, no dividing, no dividing. If I have whatever here under root positive, will I have any I? Will it be complex number?
No.
If the number under root is positive, the square root will give me the real number, right? Square root of positive number will give me real number, so I can calculate how many solutions. Two real solutions, right? So whenever my b square minus 4ac, whatever is under the square root, is positive, then the equation has two real solutions. Now, if this number is negative, will I have real solutions? No, because I will have square root of the negative number, so I definitely have that I. So my solutions will be what? Complex. How many? Two complex solutions. And when what? Okay, here's the right. Right.
Wait.
So both of these number is 0. Exactly, because if that is 0, I will have x equals negative b plus minus 0, because square root of 0 is 0, over 2a. So this plus minus kind of become not important, because it's plus 0 or minus 0, doesn't matter, I can like delete the whole thing. And now I have just one solution, and it's real, right? Right? So if this number is 0, then the equation has one real solution. And there is actually the name, you have the name for this number b squared minus 4ac, and it's called the discriminant. Discriminant. So this number b squared minus 4ac, whatever is under the square root in the formula, is called discriminant. Okay? Questions about this? Okay, so let's play a little bit with this. I have three equations. And what I don't want to solve them, but I want to figure out, based on the discriminant, what kind of solutions I will have and how many. You already done?
Yeah.
Okay, so let's think about it. What we care about is the discriminant, right? b squared minus 4ac. So just looking at this equation, do I know my a, b, and c? Yes, so what is my a? 1. What is my b? Negative 6. And what is my c? 10. So I can definitely calculate b squared minus 4ac. What is it? B squared is negative 6 to the power of 2 minus 4. AC is 1 times 10. Okay, so what is this number? Minus 4? Who calculated? Minus 4? No?
I got 26.
26? How did you get 26? I have 36 minus 40. Negative 7.
Oh, I forgot the 4.
Make sure you put the parentheses in.
Yeah.
And then into the calculator.
Especially when there's square root, right?
Negative 4.
Numbers. So negative 4. Okay. So our discriminant is negative, positive, or 0? I have a negative discriminant. Right? Negative 4, negative discriminant. What kind of solutions will I have? I will have two complex numbers. So let's do the next one. I have my equation in the standard form. So what is my A? What is my B? What is my C? 49. So B squared minus 4AC is what? b squared, 14 squared, 14 squared minus 4 times 1 times 49. What is the number?
That's 0.
Yes, I get 0 too. Right, so it's 0. My discriminant is 0. So what kind of solutions will we have and how many? One real. Very good. Yes. Okay, the last one. 7i squared minus 3. What is my a? Is it in standard form or not?
No.
Kind of is, kind of isn't, right? We are missing a term, but it's there because it's what? It's 0, right? It is 0. I can kind of rewrite this as minus 0 times r minus 3. I don't have to, but I can, right? Because it's just 0. Okay, so what is my a? 7. What is my b?
0.
0. What is my c? Negative 3. So my b squared minus 4ac is what? I'm not going to write it, I'll just calculate. So b squared is 0. So minus 4ac. I think it's 21, positive. What do you think? Because it's minus negative number 7 times 20, right? Oh no, it's not 21, it's 4 times 21. What did I do? Right? It's what is it? 84, right?
Negative 84.
84. Negative, positive, right? Because it's minus negative number. Positive 84. So the discriminant is positive, greater than 0. What solutions will I have? Teddy, what solutions will I have? How many? Discriminant is positive, quadratic equation has 2 real numbers. Yes. 2 real numbers. Questions? Questions? Okay. So let's do one of these together and then you'll do maybe one or two on your own. Okay, so the first problem is negative x squared minus 2x minus 12 equals 0. Is it in standard form?
Yes.
No, it is not.
Why is it not?
You have to divide them all by a negative.
We could, however, the standard form is just ax squared plus bx plus c, right? For completing the square, we always said we want to get rid of a. But now we don't have to, right? Because we can handle a. We know how to do that. A is in the formula. So we are good. We don't need to do anything. But we could divide, it doesn't hurt. Okay, so what is my a? Negative 1. What is my b? Negative 2. And what is my c? Negative 12. Right? So let's do the discriminant first. The instruction says solve using the quadratic formula. So we will solve. But first let's just figure out the discriminant, fill in this little box at the bottom, right? And then we will know what to expect. We will be able to check ourselves. Okay, so my discriminant is b squared minus 4ac equals b squared is negative 2 squared minus 4 ac negative 1 negative 12. Right? So that gives me what? 4 minus 48, that's minus 44. Check me. I have negative 44.
Oh.
Yes? Okay. So our discriminant negative 44 is less than 0, right? So how many solutions will I have? Bill, how many solutions will I have? It's negative. 2 solutions, both complex. Okay, so let's solve and see that very fast. We can like confirm it, right? Okay, so my formula is x equals negative b, so it's negative 2 plus minus square root, and I already know what my discriminant is, so I can just plug it in, correct? Because I already calculated. This is what goes under the square root, negative 44, correct? That is my discriminant.
Would you still do divide by 2a?
Of course, yes, because I didn't do that. So divided by 2, negative 1. Questions about this? See why I skipped? Because I already calculated the discriminant, right, Adam? Yeah? Any questions on this? Okay. So now I can just simplify it. So I'll simplify the square root first. Or I think we're ready to do it at the same time. So minus negative 2 is what? Just 2, right? This negative 2 is 2 plus minus. Now I want to simplify the square root. Negative under the radical gives me what to help? Square root of negative 44. So it's I, and then what? 12. Why is it 12? Yeah, what is square root of 44? How do I simplify that? I can do the ladder, right? 44 divided by what? 2, which gives me what? And then 2, 11, 1. So I have one pair, right? So this becomes pair. So I have I times 2 times square root of 11. And then divided by 2 multiplied by negative 1 is just negative 2, correct? Yeah. So now I will separate this into real part and imaginary part. So I'll do 2 over negative 2 plus minus, and then 2 square root of 11 over 2 or negative 2r. So 2 over negative 2 is what? Negative 1. And then I have this plus minus and the negative number in the fraction, right? So that negative combined with my plus and minus will just flip the plus and minus, right? Becomes minus plus. And then 2 over 2 is just 1. So square root of 11r. So this should be my answer. I think, I hope. Might have made some mistakes, but hopefully this is good. Right? Or you could use calculator, I guess, I don't know. Could they use calculator to simplify this? Then the I part to separate them.
No.
No?
Your calculator is not going to simplify radicals. It's going to give you a decimal. Do not give us decimals.
Is there a difference between plus and minus plus?
No, it's not, right? Because I still have two solutions. I just kind of combine, because plus negative fractions becomes like minus positive, right? And then minus negative becomes plus positive, right?
Yeah.
So that negative sign in front of this number just flipped my minus plus. So how many solutions do I have? 2. And what are they, complex or real? Complex, right? The first one is minus 1 minus square root of 11i. The second one is minus 1 plus square root of 11i. So 2 complex solutions. The discriminant told us that, and it is confirmed. Okay, so we have 10 minutes. Are we ready to do some practice problems on our own?
Yes.
I think it should, right? Yeah.
Go.